Okay, first one, remember, increases in temperature are more prevalent in the northern hemisphere, especially in the Arctic, northern Alaska. We're going to talk about today increases in CO2 and methane in these regions, and I got a good video to go along with this, so we'll talk more about that. If you guys will flip over to page 90 in your book, another thing I want y'all to add to your notes is this term called albedo. Albedo, I don't know how to say it, that's close enough. All right. So, this is a reference to how much of the sunlight is reflected off of a substance. So, on this picture on page 90, what is reflecting the most sunlight? Ice, snow, and clouds, I assume, depending on how white and fluffy they probably are. So those are things that have a high albedo, and they're reflecting lots of sunlight back into the atmosphere. What's absorbing lots of light? Asphalt for sure.
Cropland.
Water, depending on the sun's angles. Cropland. Forest absorbs a lot. So the only things that are really reflecting a lot are fresh snow and ice and clouds, okay? So that's something to keep in mind because we're going to talk about that a little bit more in a second. And this is one of our feedback loops that you need to be familiar with. So we discussed volcanoes. Okay, number 16 in our global climate change notes. Ocean currents or the ocean conveyor belt carries heat throughout the world. Now, let's go ahead and flip over to, let's see. I think it's one, I had the page written down a while ago. Where are my ocean currents? There we go, page 96, sorry. So, on page 96, we have these ocean currents. All right, here's a good picture. Now, ocean currents are important. What do ocean currents do?
Circulate water.
They're moving water. Now, in the northern hemisphere, we talked about this a lot with the Coriolis effect. Those ocean currents move in a
Circle.
what kind of circle? Clockwise direction, typically. And in the southern hemisphere, they typically move counterclockwise. Now, is anybody in here watch Day After Tomorrow? I know I've referenced it in the past. So it's a movie about 10 or 15 years old, and it basically worked on the premise of climate change is happening, and the North Atlantic current gets completely disrupted, which affects weather all throughout the world, and then basically we went into another ice age. So it's a little too much. But anyway, let's go through and let's kind of actually analyze what would happen if these currents were to change. What are some effects that we could expect? So in number 16, ocean currents carry heat throughout the world. When these currents change, it can have a big impact on global change, especially in coastal regions. So if you're looking at this picture, what happens what would you expect to happen if Iceland, which is up here, okay? If Iceland, a large portion of that ice melted, what would you expect to happen to that North Atlantic current?
It would change.
It would what? Well, I mean, so let's say the ice is melting off of Greenland and flowing into the North Atlantic. That current is bringing water from where?
Iceland.
Are y'all looking at this?
The Gulf.
The Gulf, yeah, like out of the Gulf of Mexico and off the coast of Florida. It's bringing that warm water up off the coast of the U.S., all the way up past like Iceland and over to Northern Europe there. And so if you had a large input of very cold water as that ice melted, what would you expect to happen to that warm current?
Change direction.
Yeah, you would expect it to change. I don't know if it would completely change direction because of the Coriolis effect, but maybe you stop or significantly slow down that current or movement of warm water. Now, let's say this. Let's say that a lot of this ice melts, it affects that current. What happens to the temperature off the northern coast of Europe?
Oh, it's going to be a lot cooler.
We would expect it to be significantly cooler because that warm water that would normally be heading up there wouldn't be going up there anymore, right? So that might have a dramatic change in their temperature. maybe that warm water kind of gets backed up, and off the coast of the eastern U.S., the temperature increases there. So when you affect ocean currents by having large inputs of fresh water like this, it can have a dramatic change in those currents and then where that water, that warm temperature in that water is distributed. And if you're living anywhere in a coastal area where you're normally getting it would normally be cool, but you're getting warm water brought in, which helps to kind of moderate your temperature, then it can dramatically change those temperatures. Yes?
Could it cause like a lot of flooding in places that the water goes?
Well, I don't think it would cause flooding because you're talking about water getting dumped into the ocean. So it's going to cause sea level to rise, but you wouldn't expect it to cause sea level to rise more in one area than the other, I don't think.
Is Iceland like a big iceberg, or is it actually like
Iceland, is the little island that's actually got a lot of green. The big icy one there is called Greenland. They named it differently because they're trying to confuse people, which they did a good job of. But the one that's Greenland is the one that's actually covered in lots of ice, and that's the one I said if it melts, it's expected to rise sea level about 20 feet on its own. So it's got a lot of ice. And there's a worry that Greenland can melt very rapidly because you imagine you have these large, very thick glaciers. Well, it's kind of hard to see a lot of that water melting because the water that melts actually travels down and a lot of it moves under the glacier and flows out. It's not like it's flowing on top most of the time. And so essentially what happens is you have a lot of ice that melts on a glacier. It goes under and it's going under that glacier. Well, it also causes that glacier to start to what? Move and melt quicker and move out toward the ocean. And I don't know if you've ever seen like pictures of like glaciers like calving off into the ocean. So basically it's like this exponential effect where you get ice that starts to melting as it heats up, but as it moves under, it causes that glacier to move much quicker than it normally would, and which causes it to calve off or fall off into the ocean much quicker where it would melt and then, change those temperatures. So it's one of those things where it's not like it's going to melt. The glacier's so like 100 feet thick and half of it melts and you've still got 50 feet of ice. Well, it starts to melt. You're going to have a lot of water that moves under there, and that glacier is going to migrate toward the ocean. And so it would be like an exponential increase in the melting. So I watched something not too long ago, and they were talking about like areas of Greenland had been exposed that basically no human had seen probably ever before. And so areas that are getting exposed that ice is kind of melting off of. Kind of like what we talked about with some of the glaciers, like in Glacier National Park. Anyway, number 17. Now, I will say this, Jason. You would expect sea level increase to be the same throughout the world because all that water's flowing in the sea and sea level's the same. The problem, you might see a bigger increase in some areas though because the tides are not the same everywhere. Like the tides in some place will cause, because of the shallowness of the water and the way the moon's pulling on it there, the gravitational pull. Like sometimes the tides will come in and out. Like I remember being in Maine and we walked outside and I swear like where the ocean front was, when the tide went out to low tide, you could probably walk like a quarter of a mile. Whereas like if we go down to the Gulf of Mexico, like tide comes in and out, like it might move where the water is maybe 10 feet. But it's not that big a difference. You're at the beach and like the tide comes in and ruins your sandcastle. Okay, well, like in some places, especially up north, I don't know why this is worse up there, but like you'll be at the beach and then the low tide goes out and like you could walk. It's like what was that book where the people from China, the guy swallowed the sea? Remember that? To save his brother. Isn't there like a children's book?
One of those books that says the old lady swallowed the fly.
Yeah.
It's probably not the same thing.
No, it's in a different one. Anyway, so it's like the water like dramatically goes out. So in areas where the tide is affected more, maybe it magnifies that increase in sea level. That's a good question. All right, number 17, climate soil. Here's another good thing for us to look at, the effects on soil. So climate change can affect soil through changes in temperature and rainfall. Now, if temperature increases and you have a decrease in precipitation, like let's say in California or in Mexico, like we talked about in the video the other day, then we talked about the food production, right? So let's say you have a temperature increase, you have a decrease in rainfall in an area because of climate change issues, then what would happen to food production?
It would halt.
You would expect it to decrease dramatically, right? What would you expect to happen to, okay, so let's go into the next part, which can impact the soil's viability. Viability means to? Ability to grow stuff, good. So its ability, the soil's ability to support life, to grow stuff, would decrease dramatically. Now, let's say, Colby, that you're in an area, you have a temperature increase, you also have a precipitation increase. What would you expect to happen to the soil's viability? Increase. So you may have some areas where you have shifts in the ability to grow food, it dramatically increases. In some areas, maybe it dramatically decreases. So I could see in the future, what would that do to like human populations? What would people do? Yeah, you could see definitely like mass migrations of people. I don't know that it would be like one year to the next, but if you just looked at the general overall flow over the period of a couple decades or something, where you might see these movements in people. I could see this happening like in the desert Southwest, where you have like Arizona, New Mexico, Southern California. It's very dry already. They already have shortages on water. You have lots of people that live there because they like the climate. But eventually you run out of enough water to support the people that are living there and to support their needs. And so maybe those people start, moving out of those areas. It becomes much less sparsely populated like it was previously. So maybe that happens as these changes occur. Soil's viability and potentially increase erosion. Let's say we take an area like California, Chaparral, where it's hilly. You already get fairly hot, dry summers, and you get cool, wet winters. So if you increase the heat and dryness in the summer and you have more what? The hotter and drier it is in the summer, the more likely you are to have forest fire, wildfires, good. And so the more wildfires you have, and when you have a cool, wet winter, what happens? Erosion. So it's going to wash away soil. And that's why California is notorious for having what? Like mudslides, right? Because you have, or landslide, whatever you want to call it, where you have lots of land that is dispersed because there's not much vegetation there to hold it. And so maybe climate change magnifies some of those issues with increased heat, increased dryness in the summer, increased wildfires, and then you have maybe more moisture in the wintertime, which causes more issues with erosion and displacement of soil. All right, number 18. The Earth's polar regions are showing faster response times to global climate change because of snow and ice in these areas reflect most of the energy back out into space, leading to a positive feedback loop. So it's important. I know Luke knows this because we cover this quite a bit in AP Bio, positive and negative feedback loops. But these are two terms you need to know and understand and get some examples. So a positive feedback loop is when some phenomenon is moving further and further in one direction. Okay? You got that, Harry Styles? All right, so One Direction, Harry Styles.
I didn't know you were talking to her. I thought you
What are you talking about?
I was calling Quinte. It's okay.
What's that shirt you're wearing? Stranger Things. What is your problem?
Millie Bobby Brown.
Okay, so where was I going with that?
I have no idea.
I got one.
One Direction. Sorry. Okay, so positive feedback loop. We said a while ago that ice does what? Melts. But it also, when sun hits it, it reflects a lot of sunlight. So it reflects a lot of sunlight, so it reduces radiation. But let's say you increase the temperature and melt a lot of that ice. Then that ice is going to turn into? Water is going to absorb more heat, which is going to cause more ice to melt. And so because it's warmer, it's going to cause more ice to melt. That ice is going to turn into water, which is going to absorb more heat, which is going to cause more ice to melt, which is the less ice there is, the more heat that's going to get absorbed, and it's going to keep going in that direction. That's an example of a positive feedback loop. It's a phenomenon that's getting pushed farther and farther in one direction. Okay? Luke knows about this because we talked about birthing children and fruit ripening. So it's two different. What? Yeah. So negative feedback loop. Let's talk about one of those. Let's say that negative means something's going in one direction and it moves it back in the other direction. So we have a pretty dramatic increase in CO2 levels right now, right? So let's say on 520, maybe 530, huh? See if we can get these CO2 levels. So let's say we increase CO2 levels by burning lots of fossil fuels. Well, what happens to the CO2 levels if you have more CO2 in the atmosphere from burning fossil fuels? What do you think plants are going to do if they have more CO2 available to them? Maybe they start absorbing more. So we see these CO2 levels increasing pretty dramatically here over time. But maybe we get to a point where because there's more CO2 level, if we don't chop down all the plants, right? Then those plants are able to absorb more CO2 just because it's a higher concentration. And maybe it starts to move that number back down. Or maybe even like with the oceans. What do we say? The more CO2 in the atmosphere, ocean water's moving around, maybe they absorb more CO2 in the oceans, which causes ocean acidification, but maybe that also reduces atmospheric CO2. So anytime that you have a phenomenon that where something's going in one direction and something brings it back the other way, that's a negative feedback loop. Okay? That makes sense? That's like sweating. You get hot, you sweat, and it brings your temperature back down. So that's a negative feedback loop. Negative doesn't mean bad. It just means it's moving it in the other way. All right, number 19. And this explains it, what we just went through, number 19 here. As the Earth warms, the ice and snow melts, meaning less solar energy is radiated back out into space and instead is absorbed in the surface, either on land or in the water. This in turn causes more warming, which causes more ice to melt and so forth. So number 19 is basically what we just talked about on the positive feedback loop. Okay? And then number 20. So we're going to get into this in the video today, so I want to go ahead and hit it real quick here. Global climate change response time in the Arctic is due to positive feedback loops. So this is where that kind of increase that we were talking about, maybe why it's warmer there than it is in other places. Involving melting sea ice, okay, because there's not as much ice reflecting it, so it's absorbing more, so that would make sense why it's increasing faster. There we go. And then thawing tundra. The tundra's got lots of frozen permafrost, yes. So it does have lots of ice and other stuff, but that melts in the summer. But underground, it has lots of permafrost. So the thawing tundra, you start to melt out that permafrost. The subsequent release of greenhouse gases like methane and CO2, and that's going to come up in the video today. One term that you need to add in your notes that's not in here but was on a test recently is called methane hydrate. So there's a lot of methane hydrate that's found throughout the Arctic regions. Hydrate means? Water. Methane is? Methane. Good. So when it's frozen, you have this methane that's really cold and mixed in with water, and it can be frozen. And then if you put a flame to it, then what would you expect to happen?
Blows up.
Yeah, it can blow up. So we're going to see some of that. Well, I mean, it would melt and blow up. And so the term for this that you see a lot is called fire ice, where you basically have methane that's in the ice that will catch on fire. And so that's what's going to come up in the video today.
What is burning ice?
Burning ice?
Yeah.
Ice that's on fire?
I would think it's the same thing. Where have you heard of burning ice?
I mean, like, some people say, like, ice can get cold to a point where it burns.
Oh, like you have freezer burn on your skin.
Oh, yeah.
That just means it's like, it's not, I don't guess it's technically a burn, but it's like, it's deteriorating your tissue in a similar way a burn would.
Okay.
And it causes blisters, the same kind of stuff you get when you're exposed to too much heat. Yeah?
What was number 19 again?
You're 19. As the earth warms, this ice and snow melts, meaning less solar energy is radiated back into space and instead is absorbed by the Earth's surface. This in turn causes more warming in polar regions. It's that whole thing we talked about with the positive feedback loop. Yeah?
What's the second part, number 18?
You're 18.
What's the first part of 18?
Because ice and snow in these regions reflect the most energy back out into space, leading to a positive feedback
What's
loop.
the first part of 18?
Earth's polar regions are showing faster response times to global change. So the increase in temperature there that's higher in the Arctic is due to that. You've got melting ice. As it melts, you've got more water, which means it's going to warm up faster because it's going to absorb more heat than it's used to. Yes, sir.
What's the first part, 17?
God bless America. 17, climate change can affect soil through changes in temperature and rainfall. which can impact the soil's viability and potentially increase erosion.
They do not give us enough space to write all this stuff.
Yeah, I made all these lines. That's my fault. All right. Blame it on me. Old McDonald did it.
There's no time to write it down to. It's like 6 words, and then you just keep going.
Don't blame it on
And then like I have to remember one of them.
Yeah.
Whiners.
Sometimes I try to like write them halfway, then start the other one. That way, like if I'm looking at the other one,
I can just see y'all in a college class and just like, Professor, there's like 300 people in the classroom. Can you back this up here? Can you repeat that for me?
I usually okay, well then again, you are recording this, so like worst comes to worst, I can go home, and they do that in college.
Yeah, you're never gonna do that. All right, so,
Yeah, no.
Yeah.
If it's
well,
something-
okay, we're gonna stop there. That's good. We're on number. What do we get to? Number 20.
21.
Okay, we'll stop there.